Hi, welcome back to part 2 of my video on redefining how we model, manage, and improve software development activities today. In part 1, I used the analogy of a closed clock to describe our inability to understand the behavior of software organizations and projects today. In this part 2, I will give a brief overview of how we have come to view the world and describe why I believe it is important that we understand how this came about. Let me start this part by describing a different way of looking at the information I will cover in this video that might give you a better understanding of where I'm going. The general purpose or direction of this video is to describe a way that I believe will help you better manage and improve your software organization. In order to manage our companies, we must acquire an understanding of how software organizations work, for it is, in fact, this understanding that guides us in making decisions and taking actions and directing our company. In order to acquire this understanding, we need to be able to communicate our theories about how software organizations work. And our theories of how software organizations work are based on each of us constructing what we see as plausible theories of how they work. But what do we do when we have little direct observations, as I mentioned in the first part of this video, or when it is not clear what actions or decisions we make causes what effects? In such cases, like trying to understand the closed clock, we must rely on existing mental constructs from which to pull from in order to construct our theories. Let me give you a specific example in history of how this works. When physicists in the early 20th century needed to construct a model of the atom, they were faced with a situation similar to the closed clock I described in the first part of the series. They knew atoms existed, and they could measure the effects of experiments that were conducted on them, but they couldn't actually see them. And without real visualization of the atom, the physicists proposing models in the early years of the 20th century had to borrow liberally from their existing experiences. The first notable model of the atom was that proposed by J.G. Thomson in 1904, who was credited for discovering the electron. In his plum pudding model, Thomson envisioned electrons, later referred to as plums, arranged in some ordered rings inside of a soup or pudding of positive charges. After a 1909 experiment disproved the plum pudding model, Ernest Rutherford drew from his mental image of the solar system when in 1911 he proposed his model of the atom. In this model, Rutherford envisioned a core of subatomic particles surrounded by a cloud of orbiting electrons. Then in 1913, in the wake of new experimental data that had not been available to Rutherford even just a few years before, Niels Bohr proposed that electrons revolved around a nucleus of positively charged particles, just as planets revolved around the sun. He then expanded on this basic concept by suggesting that electrons jumped between orbits, thus explaining the observed absorption and emission of energy by atoms that Rutherford model could not. The point of this discussion of the atom is that in each case, these physicists or creators of models constructed images of the atomic system based on pre-existing constructs in their own heads, whether it was a plum pudding, spinning electrons around a core, or a solar system-like image of the electrons around some type of an atomic nucleus. So what do we do when we want to construct a theory that describes how our software organizations or projects work? Where do we begin to mentally construct our theories? Just as the ancient Chinese proverb says, the last thing the fish sees is the water, what we often don't see are the mental constructs that we have been programmed with. In essence, tools in our mental toolbox, tools that we use as a basis for creating models about how the world works. So whether the system we're attempting to model is the Milky Way galaxy, a clock, or a software project, when we want to create a model of how these systems operate, we naturally pull from these mental constructs and then use those as building blocks for creating our new theories. So before we jump in and start building models of software projects, I think it is essential that we first understand what are the mental tools that we are likely to use in this construction effort. Why? Well, there's an old saying that I think applies here, and that is, if you give a boy a hammer, everything is a nail. If we only have one or two tools at our disposal to use to fix our complex problems or to improve our software organizations, then everything we see and how we think about the situations that we encounter will be influenced by the tools that we have available to use on them. Or to think of it differently, if we only have a hammer at our disposal, then every problem is a nail. And while this video series might be about creating an exploration into modeling activities, I also want to suggest that it is about, and maybe even more importantly, adding new and hopefully better tools to our existing mental toolbox. Tools that will help us to construct more accurate representations of our organizations. So what do we have in our mental toolbox that we can use to construct these theories? To help understand this, I'm going to ask that you stick with me for about 10 minutes while I take a quick tour through some important points in Western history that will help us to first understand how we have come to build and use the tools that we currently have at our disposal for managing and improving software organizations today.